I'm Kelsey, an OpenSciEd teacher and facilitator. This video is going to go over Lesson 11 and Unit 6.2. How we got here. In Lesson 10, we figured out that the movement of particles is related to the temperature of the water, with particles in colder water moving less than particles in hotter water. So in this lesson, we're wondering why? Why do particles move more in hot liquids? Here's a lesson at a glance. This is an investigation lesson. We've got a one-day lesson here with 20 minutes of material prep. No hands-on investigations, but we do not require devices and we do not have any videos. So we have one sense-making loop in this lesson. We start by looking at the evidence we have gathered so far, and we examine two claims for what could make the liquid warm up. Then we examine a quick simulator that shows particles of a liquid at different temperatures, followed by a building understanding discussion and an opportunity for students to practice using what they have figured out by explaining what they saw in the food coloring lab in the previous lesson. From this, we figure out that the particles of warmer liquids have more kinetic energy than particles of colder liquids. So in this lesson, we figure out that a particle's speed is related to how much kinetic energy it has. The particles in hot liquids and gases have more kinetic energy than the particles in cold liquids and gases. And liquids and gases are made of particles that can move around freely. From all of this, we're left wondering, how does the motion of particles compare in a sample of matter at a given room temperature or given temperature? Key moments. So the key moment in this lesson is going to be part 3, the building understanding discussion about kinetic energy. So when students look at this simulator, they can clearly see the particles moving around and bumping into each other. They can clearly see that particles are moving faster when they're hotter and slower when they're colder. So during this discussion, you start to make connections to what we already know about energy. We know it's not matter. It's not made of particles. There's different forms of energy. It can be transferred. So here you introduce the term kinetic energy to your students. So kinetic energy, the energy of motion or movement, things that are moving have kinetic energy. This is where I start to use my hands as particles and moving around, bumping into each other, and the students start to do that too. We start practicing using the term kinetic energy, explaining when the sample in the simulator had more or less kinetic energy. And we also add to this model that we created in the last lesson. So you can see in this example, they just add to the key. So they have these longer and shorter arrows showing movement, and they're adding to the key to say that they also mean more or less kinetic energy. And there's a different way they've added it down here as well. This is how I have done it with my students, where instead of longer, shorter arrows, we used dotted arrows, less movement, solid arrows, more movement, and then we just added that also means more or less kinetic energy. So it's a simple thing that we're adding on here, but now we not only know that warmer liquids move faster than colder liquids, but they also have more kinetic energy. So material management tips and tricks. I just want to talk a little bit about part 1, the navigation in this lesson. And that is where we have this claims chart. So this claims chart is given me trouble before. I know it's given other teachers trouble as well. So I found some things that kind of help. So from lesson 10, we know that particles move more in hotter liquids, but we aren't sure what causes them to change temperature. So that kind of motivates this navigation, and it starts to ask students to use evidence to support these claims. And these claims are very common ideas like heat going in or leaving, and also cold going in or leaving, cold moving. They're very common ideas, so you definitely want to bring them up. But just some things that might help is that at this point, the students might put a lot of evidence under claim 2. And that's fine. That's good. They're going to debate. And a lot of times my students say, well, I want to put this piece of evidence in between 2 claims. And all of that at this point is fine. This activity is just to elicit some ideas, to get the ideas out there. It's also great practice for the students to begin using evidence we've gathered, which is good because you're going to be asking them to do that going forward. And it motivates the need to continue investigating. So it's not something that you really need to like dig into and spend a lot of time on and try and push your students to the quote unquote correct claim. um, it's just to elicit ideas, practice using evidence. Something that might help is to frame the students' thinking with a cold drink warming up over time. So, if a cold drink warms up over time, this is the phenomenon we've been talking about this whole unit. We have a couple claims: either heat is entering or cold is leaving. That kind of helps them frame their thinking around the claims. But just remember that you're going to come back to this, so you don't need to spend a ton of time. In the final navigation piece of this lesson, you go back to the ice drink anchor phenomenon and problematize that if it's warming up, it's gaining energy. So, where might that come from? And that again moves you forward. So, hopefully, that helps this claims chart navigation piece. So, we add kinetic energy to the word wall in this lesson. It's very important. And for poster management, the claims charts, they don't have to stay up. You're going to use them again. If you have a ton of space on your wall, you could keep it up, but it's not necessary. I don't have a ton of space on my walls, so I usually store them and bring them out when we need them again. The models that you added on to from last lesson, those are important. They have important things that we have figured out in the past two lessons. I put them up on the wall for the remainder of the unit. And that's it. In lesson 12, we're going to investigate how does the motion of particles compare in a sample of matter at a given temperature. And that'll be the next video. See ya.